Hey guys, today in this tutorial we're going to be going over recreating the video game QWOP in Unity. We're going to go over the basics of how we would create a movement system like this game. The movement system in this game works by moving the thighs apart with W and moving them in closer with Q, and then based on the leg movements trying to gain as much distance as possible in the game. So we're going to look how we can recreate that system in Unity using hinge joints. So here in Unity we have what our end goal will be. We'll be able to move the legs with hinge joints, the calves and the thighs, just using QWOP on the keyboard, setting up a collider so when the character falls over as well, that you'll be able to restart the game by pressing space and it will reload the scene. So we'll just go over how we set all of this up. So the first thing we'll need to do is just set up a 2D Unity scene. So when you create a new project, just click on 2D. Or if you've already got a scene open and it's in the 3D mode, you can just click on 2D here and it'll give you a 2D mode. We'll just need to make sure our camera is orthographic. And the first thing we'll want to do is just drop out our background. And this is just a simple sprite that I was using as the background. And we can just adjust the size so it lines up with the camera. And then simply what I'm going to do as well is add a 2D object to this background, and it's just going to be a physics object and a static sprite. We can delete the sprite component, and essentially all that's giving us is a box collider 2D. In fact, we don't even need the rigid body, so we can remove that component as well. And essentially we just want to place the ground in for when the player falls over and we'll get a restart. But it will also act as our physics system so that the player's legs will interact with it and be able to move along this box collider. The next thing we'll need to do is create an empty, and we can just call this player. And I've got a sprite sheet here where I've just essentially taken an image, I've spliced the arms, thigh and calf separately, and I'm going to use that to recreate a player body in here. If you've got a sprite sheet and it will come in as a single image, so what you want to do is go to sprite mode, select multiple, and go into the sprite editor. And in here you'll be able to select each sprite separately. You can also do it automatically using the slice tool and going to automatic, or you can just draw a box around various parts of the image and have that be your sprite, but I'll just delete that. And we don't need to apply those because we've already set up our sprite sheet. So the first things I'll do is just drag out this body sprite, and you'll notice straight away that we can't see it. And that's because all the sprites in the scene will be on layers. In the background's layer 0, and this is on layer 0 as well. So we'll just need to bring that to 5, and now you can see the character. And if we just move him along, and we probably can make him a little bit smaller as well. Okay. And so we'll now need to set up the thighs and how they relate to the body. So we'll just call this body. So we'll add in 2 sprites here for the thighs. In fact, I'll add in one first. And again, we need to make sure it's on a high enough layer. And if we say this is 0.5, 0.5, 0.5, and we can do the same for the scale here. And then we move the thigh down and across. And we may even want to rotate it a little bit for its starting position. And then we can call this thigh right. And then what we want to do here is add a hinge joint, and this hinge joint 2D will allow us to connect these 2 sprites together and show them interacting, or have them interact around a hinge. So if we just zoom in, and the first thing we'll want to do is, so what we'll want to do here is add a box collider 2D to the object, and we'll just want to bring this down so it lines up a bit better with the actual leg. And here I'm just doing it roughly, but obviously the neater that this image fixes into the box collider, the more accurate it will be. So next we'll want to make sure we set up the hinge. So we'll want to click here to edit the hinge location, and I've deselected that, but if we just select that and then go up here, and that's roughly what we want. We then want to set some angle limits down here. So we want to say how far it can go backwards or forwards along this hinge. So if we do, let's say -60 to 60, and then say use limits here, you'll get the range in which the hinge can move. So if we just click play here, and you'll be able to see how the hinge interacts with the body. And we'll also want to make sure the body has a box collider 2D on it as well. And we'll just line that up. And we'll just line up the box collider so it's roughly around the body. And I think we also want to add a rigid body 2D to this. And that will give it a gravity and a mass that will be simulated. Now if we click play, so one thing I forgot to do there is if we just go to the phi, and we need to say what rigid body it's connected to, and we just put in the body object here, and now they're both connected. We don't enable collision, and then with everything we've set up here, you can see the phi now will move and pivot around that angle, and then the body will also fall. And so we can just duplicate the right phi using Control D, and we'll just call this phi left. And it pretty much will have most of the same properties. We can move it slightly, line it up differently, and I'll just move it down in the layer so it's not overlapping with the other phi. And there we've got both the phi set up, and they're connected, and the angles are set. Now we'll need to set up the calves for both, so we'll just create a new sprite, put in here, and call this calf right. And then it needs a rigid body 2D, box collider 2D, and then if we just say 2 on here for the layer so we can see it, and we're just going to say 0.5, 0.5 in all the axes. And we're going to set up very similar to how we set up the phi, and we're just going to add a hinge joint 2D. So hinge joint 2D, and we'll this time attach it not to the body but actually to the phi. And then we'll also need to use limits, and we can set, you know, whatever angle looks best for our sprites, how much mobility we want to offer the player. And then if I just duplicate that, call it calf left, and attach this one to phi left instead of phi right. So we just move that in here. And then everything else should be the same roughly. On the layer, we probably, we do want to move it along. And on the layer, we want to set it to 1. Now, another thing we need to do with all of these is make sure that we've set our hinge joints where we want them. So I'll just go through each one and make sure I'm happy with where the hinge joint's located. And this one as well. And we'll move this hinge joint. And this hinge joint as well. And then if we just give that a quick play to make sure everything looks okay. So we're getting the movement we want. Obviously, depending on the sprites you use, it may look disjointed or not, and the angles you use also. So I might move that around slightly. Also, another thing we're going to add is the arms. So what I'll do here is add the right arm. And if we just put that on layer, let's say 6, and we just scale it down to the right size, and I'm just going to move this down to here. And then we just need to go through the exact same process of adding a hinge and a box collider. Make sure I'm happy with the box collider's size and where it's set up. And we just want to attach the hinge to the body. Make sure the hinge is in the right place, which is where the arm would connect to the body. And then we can set a angle limit. And this could be, minus 45 and 45. Now, in this movement system, you're not going to be moving the arms with buttons, but just like in the QWOP game, the arms kind of flail around, move around, and it gives you that kind of physical indicator of the character moving. And we'll just pop this down into the player. And if we just duplicate that as well, call that left arm. And if we just change the sprite to the left arm sprite and I move it along, and I'm just going to set that to layer 4 so it's underneath and it's connected. I can move the hinge also where I think's best, and I can change the angle if necessary. And I'm just going to go over quickly and check that all the box colliders are good. So that's fine. This is far too large. So that looks good now. Do the same for this box collider, just set it up to be a bit smaller, and it should be on the calf. Okay, now that I've edited all the box colliders to where I like them best, I'm just going to click play and show you how this pans out right now. So one of the problems you're going to get is all of these objects have colliders on them, and we don't necessarily want them to interact with one another. The legs should just pass through each other easily. And a really easy way to do that is just to set everything on layers and then have those layers only interact with each other if necessary. So what I'll do here is go into layers, and as you see, I've set up right leg, left leg, arms, and ground. And this way I can put things on the appropriate layers. So I'll just go through the right legs and set to 6, which is my right leg layer. Same for the calf. And it's the exact same process for the left leg. And the arms I'll also put on the arms layer. And then once all the layers are set, I'll also set the background to ground. In fact, I'm only going to do this for the ground hitbox. So if we just rename this, as you can see, the ground hitbox is down here, and I'll just set this to the ground layer, which will be relevant in the future. We go to edit, and then we go to project settings. Then in project settings, physics 2D, and scroll down. And I just want to make sure that the arms don't interact with the ground or the arms. The left leg doesn't interact with the arms or the right leg, and the right leg's also not interacting with the arms. So if you just want to look at that setup that I've done, and that'll just give us a smoother interaction between all these objects. So if I save that, click play again. Now the legs aren't interacting with each other, but obviously he's off balance and falling over there, which isn't great for a starting position, but we can fix that in a bit. So the main thing we need to do now is we need to add motors to the legs. So essentially, if you go into the hinge joint, you'll see there's a use motor function. And what we're going to do here is set this off and on based on whether the player is pressing Q, W, O, or P to move the legs. So we're going to have to do all of that in a script. So what we'll do here is we'll add a script, new script, and we'll call it player movement. And if we just open up that script, So once we're in the player script, it's pretty simple to set up. We first need a reference to all our hinges that we've set up. So we'll just say hinge joint 2D, and then we'll have right phi, for example. And then we just need to do this 4 more times. So I'll just copy and paste. But instead of right phi, it will also be left phi, and then right calf. And then the last one is left calf. And then we'll also need to set up 4 more variables, and this will be for the hinge motors, so the joint motor. So it's joint motor 2D, and we'll call this right phi motor, and we're going to call it reference. And we're just going to do this, 3 more times, but we're going to have to rename them all depending on what they're for. So we've got left phi motor reference, right calf motor reference, and the last one is left calf motor reference. Okay, and then so now we've got a reference to all our motors and joints. We'll then need to assign our motors based on our joints. So what we'll do here is say right phi motor reference is equal to the right phi joint dot motor. So we're going to the right phi joint, and we're finding what its motor is, and we're assigning it to this reference. The reason for this is in the update function, we're not allowed to directly edit the motor, or it doesn't allow us in Unity. What we need to do is change the reference speed and then reassign it at the end, which should make a bit more sense once we get through all of this and write it all out. So I'm just going to copy and paste this 3 more times, and then, as we've been doing so far, just reassign the names. So we have left phi motor reference is for the left phi motor. We have right calf motor reference, and that is for the right calf motor. And then it's just left calf motor reference, and that will be for the left calf motor. And I just missed the capital there, and then we'll set that up. So now that's all set up, we just need to start getting the inputs. So anyone who's played QWOP before will realize the input's pretty simple. QWOP are all the 4 letters to move the various limbs. The mechanics behind that's actually relatively simple, and I'll go back to Unity to show this. Basically, whenever Q is being pressed, the phis will be rotating towards each other. So this phi would rotate that way, and this phi would rotate down that way towards each other. And then with W, they both rotate out. So rotates this way, and this phi rotates this way. So if we go back, the same for the calves, the rotations are the same. So we'll just need to make sure that the motors are basically going in the opposite directions of each other for the phis and the calves, depending on what buttons press. But if we go back into the script, that should be pretty straightforward once we write all of this out. So we'll say if input dot get key code, so we get key and then we put key code, we want Q for the first one, and this is both the phis moving towards each other. So what we say is right phi dot motor equals true, so the motor will be on. Oh, sorry, it's not motor, it's use motor equals true, and left phi dot use motor also equals true. Then what we need to do is set the motor speed on our references. So we say right phi motor reference dot motor speed equals, and probably the best thing to do here is to set a float that we can use as the hinge speed. So we'll just call it 40 is probably good. And because this is going to be going in the counterclockwise direction, we need to do minus hinge speed. And we'll say, sorry, it's left phi motor reference dot motor speed. And this is going in the clockwise direction, so we'll just do positive hinge speed. And then we need to assign the right phi dot motor is equal to right phi motor reference. And if we do the same, for the left phi motor dot motor is equal to the left phi motor reference. So if you don't get what's going on here, essentially we're saying up here that the right phi motor reference is equal to the right phi motor, so it's getting its properties and assigning it. Then what we're doing is changing the speed of the reference and then reassigning the reference back to the original motor that will affect the joint. And therefore we're able to affect the joint motor directly, essentially. Now what we then need to do is say, well, else if input key, so input.key, and then it's W, key code W. This will be the opposite, so it's doing everything in the opposite direction. So we just copy this code block, paste it in, and we just change from negative hinge speed to positive hinge speed and vice versa. And because this is only for the phis, Q and W, this will be all we need. And then just a final else statement that says, you know, if neither of these keys are down, because both of these statements are returning false, then we don't need either motor to be moving. Because if the key's not down, then the limbs of the character aren't moving. So from there, we just need to do the same, but we're just going to do it for the calves. So I'm going to copy this entire code block, and it's just a bit simpler to do it this way. So from Q, we're now moving over to O, and we're no longer doing phis, but we're doing the calf motors. So we'll just replace all the phis with calves. And again, here it's P, and we just replace all the phis with calves once again. So if we just save this, now this is all our movement, all set up for the character. It's very simple to get set up. Yes, it's typing a lot of variables out, but the system's actually pretty simple. It's just a couple of hinge joints on each leg. Okay, and back in Unity, what we need to do, I just realized that I've got the player script on here, the phi, but in fact, I think I'd rather have it on the body. So if we just put the player movement script here, and we just need to assign the joints that we set as a public variable. So if we say phi right here, left phi here, calf right here, and left calf here. And if we just play this, and as you can see, we can now move the phis and the calves quite easily. Now, obviously, my joints are currently a bit misplaced. So what I'll do is I'll just try and move them about, see if I can get them in a slightly better position. Okay, so I'm just moving the phis and calves around a bit, just so I can get the correct position I want on them. So I've just played around with the phi position, the leg positions. I changed the calf angles from -30 to 30. And depending on the sprite you're using, the lengths and the proportions, you'll want to play around with it, get the angles and movements you want correctly. But now if we look very simply, if we press W, we get the legs spreading apart. We can move the calves, so the legs at the bottom, and then we can press Q as well to bring the phis together. And very simply, we're now in a failed state, so our player's fallen over. So we'll need to set up some code as well to restart the game if we reach a fail state like the one here. So if we just leave play, and we'll need to set up that script. Okay, so to set up the fail state part of the game and restarting the game is pretty simple. We just need to first create some UI. So we'll go into UI canvas, and then within the canvas, we just want to create more UI. And let's do a text mesh pro, and we'll just call this restart text. And if we move towards the canvas, we can see it here. We'll just pin the restart text to the top of the screen. So we can click here to set the pivot point, and we can also shift and alt click to set where it's anchored to. So alt click will do the anchor, and I believe a normal click will be the pivot. And then we'll just say something like -50 in the Y position, and we'll just say press space to restart. And then we'll just try and center that out ever so slightly. Let's see. And then let's see, center. And we can even increase the font size if we want. And then I'll just move this along till it roughly looks like it's in the center of the screen. And that's perfect. We've got the text there ready. By default, I'll turn the text off in the inspector. And then if we just go back to the player, we'll just need to add a script, and we'll call this game over script. Next, we'll load up that script and just have a quick look at it. Okay, so we'll need to set up a couple variables. So I would say public bool dead, and then that just equals false. And then a public game object, and we're just going to reference the text, so we'll just call it text. We don't need the start function, so we can just delete that. And in the update, very simply, we'll say if dead is true, then we'll do text.gameObject.setActive is also true. Then another if statement will be if input.getKey keycode space. So keycode.space. That's if the spacebar is down. We'll also want to put another condition here, which is and dead equals true. So they can only restart the game if they're in the dead or game over fail state. Then from there, we'll just need to make sure that dead equals false. So the game has restarted. The text is also set to unactive, so we no longer can see the text anymore. So we just say set active is false. And we need to load the scene again. So we'll just say scene. Oh. It doesn't like that because we need to make sure we're using the correct library, which is Unity Engine .scene management up here. And once we've done that, it will recognize this code. So scene. We're just getting our active scene. And then we're just reloading that active scene. So we just say scene manager once again, load scene, and we'll just put scene.name, which is the scene we've just got, which is our active scene. So that will just reload the scene as it is by default. And one thing we'll need to do is also detect when we're dead. So what we'll need to do is actually create a new function and say private void on collision enter 2D if collision .gameObject.layer is equal to 9, which is our ground layer that we've set up earlier, then dead equals true. And very simply, that will give us our game over state. So if we go back into Unity, you'll be able to see here that on the ground hitbox, we made sure that it was on the ground layer. So if we then go back to the player, zoom out a little, now we can click play and everything should work from there. So we've got movement on our player, and if we fall over, we've got a problem. And that's so the first thing we'll need to make sure we do is, if we go to the script, we'll just need to make sure the restart text is referenced. And if we clear these error messages, then if we click play, so now everything's working as it was before. We can move the legs with QWO and P, and if the player is to fall over and get a failed state, we get press space to restart on screen. And once we've clicked space, we've restarted the game and it's back in the default position. So I hope you like this tutorial that showed you how to recreate the movement system from a game like QWOP. And then from here, you should be able to build out something kind of cool, something interesting using these hinge joints and using this simple code. I've seen other games like this. I think there was one was a horse and you had 4 legs and it had a slightly different movement system. But this should give you a good understanding of hinge joints and how they interact with each other and how to set their motors on and off to create movement in a 2D game. Thank you for watching. Goodbye.